Hello, this is Paranormal Girl. Oumuamua. Is it an alien ship? Or is it just a piece of space rock? Oumuamua is Hawaiian for first scout from a distant place. This mysterious interstellar object that crashed through our solar system almost 3 years ago might, in fact, be of alien technology. That's because an alternative, non-alien explanation might be fatally flawed, as a new study argues. But most scientists think that this idea that they spotted alien technology in our solar system is really a long shot. Back in 2018, our solar system ran into an object lost in interstellar space. This object, dubbed Oumuamua, seemed to be long and thin and cigar-shaped and tumbling end over end. Then close observations showed it was accelerating as if something were pushing on it. Scientists still are not really quite sure why. Well, an explanation may be this object was propelled by an alien machine such as a light sail, a wide millimeter-thin machine that accelerates as it's pushed through by solar radiation. The main proponent of this argument was R.V. Loeb, a Harvard University astrophysicist. Most scientists, however, think Oumuamua's wonky acceleration was likely due to a natural phenomenon. Back in June, a research team proposed that solid hydrogen was blasting invisibly off the interstellar object's surface and causing it to speed up. But now, in a new paper published, the astrophysical journal Letters, Loeb and Theum Hong, an astrophysicist at the Korean Astronomy and Space Science Institute, argue that the hydrogen hypothesis couldn't work in the real world, which would mean that there is still hope that our neck of space was once visited by an advanced alien race, and that we actually spotted their presence at the time. But here's a problem with Oumuamua. It moved like a comet, but didn't have the classic coma or tail of a comet, said the astrophysicist Darrell Seligman, an author of the solid hydrogen hypothesis, who is starting a postdoctoral fellowship in astrophysics at the University of Chicago. Oumuamua was the first object ever seen flying in our solar system and back out again. That, opposed to most solar system objects that turn circles around the sun, never leaving the celestial neighborhood. Its journey and the fact that it was accelerating suggested Oumuamua, which is estimated to be around about 1,300 to 2,600 feet long, was a comet, and yet there was no coma or outgassing detected coming from the object, Seligman said. Normally comets come from regions more distant from the sun than asteroids, and ice on their surface turns straight into gas as they approach the sun, leaving behind a tail of gas, or what we see as the beautiful comet tail, he said. The outgassing changes how the comet moves through space. It's a bit like a very slow rocket engine. The sun strikes the comet, the warmest part of the comet bursts with gas, and that gas flowing away from the comet sends it tumbling faster and faster away from the sun. In a paper published June the 9th, the astrophysicist journal Letters, Seligman and Yale astrophysicist Gregory Laughlin proposed that the object was a comet made up partly of entirely of a molecular hydrogen. In other words, lightweight molecules composed of two hydrogen atoms, which are H2. The H2 gases freeze into like a puffy, low-density solid only when it's very cold, which is 434.45 degrees Fahrenheit or minus 259.14 degrees Celsius, or just 14.01 degrees above absolute zero in the Earth's atmosphere. Researchers had already proposed the existence of hydrogen icebergs out in the very cold reaches of space. Laughlin and Seligman wrote in the study an outgassing hydrogen wouldn't be visible from Earth, meaning it wouldn't leave behind a visible comet tail. The numbers worked out neatly. While a few other substances like solid neon could potentially explain the coma-free acceleration, hydrogen was the best match for the data. But in their new paper, Hong and Loeb respond to their ideas and argue that the hydrogen iceberg explanation has a basic problem. Comets form when icy grains of dust bump into each other in space and form clumps. Then these clumps attract more dust and other clumps. And comets are kind of like snowmen. They only survive for as long as they don't melt. The stickiness that helps form comets is similar to the stickiness of ice cubes coming straight out of the cold freezer. Leave an ice cube on the counter for a minute or two, let its surface warm up for a bit, and it won't feel so sticky anymore. A thin film of liquid water on its surface makes it slippery. Hong and Loeb argued that even starlight in the coldest parts of space would warm up small chunks of solid hydrogen before they could clump together and form a comet of Oumuamua's large scale. And more importantly, the trek from the nearest giant molecular cloud, a dusty, gassy region of space where hydrogen icebergs are thought to form, is far too long. The hydrogen iceberg travelling hundreds of millions of miles through interstellar space would have actually fallen apart and been cooked by starlight. Seligman said Loeb's analysis was correct and that no hydrogen comet would survive such a long trip. Hydrogen icebergs don't live that long in the galaxy, he said, and you definitely don't have time to go all the way from, say, the nearest giant molecular cloud. The theory only works if Oumuamua is just 40 million years old, he said. Over that time frame, outgassing could have molded the comet's oblong shape without even destroying it entirely. He pointed to a paper that he'd published in April in the Astronomical Journal, which proposed a number of nearby origin points of Oumuamua. The paper's authors didn't nail down the comet's home entirely, which would be impossible, they said. So in other words, they don't really know, do they? Oumuamua was hardly moving when it arrived in our sun's gravity, which makes tracking the comet through space very tricky indeed. But the researchers looked at what else passed through the Milky Way neighborhood that our sun is now passing through in recent cosmic history. They landed on two groups of young stars, the Carina and Columbia moving groups, said Tim Hallett, a graduate student of the astrophysicist at the McGill University in Montreal, and the lead author of the paper published in April. He said they all formed around 30 million to 45 million years ago in a cloud of gas that then dispersed. That small dissipated cloud of molecular gas with just a few young stars is one where hydrogen icebergs might form, he said. There are many processes that could eject Oumuamua type objects from the young stars in the moving groups, like, say, gravitational nudges between stars in the group, planet formation, or, as Seligman and Laughlin back in 2020 argue, the molecular clouds that create the stars in the first place could be that idea as well. Seligman and Laughlin's idea could work here, but H2 objects should have a short lifetime in galaxy, as Loeb correctly concludes, and an origin in Carina or Columbia would make it young enough to survive its journey, he said. However, Loeb disagreed on this. Shortening the distance that the H2 iceberg needs to travel does not solve the problems that we mentioned, because the H2 iceberg would have formed when its parent planetary system formed billions of years ago. And in those eons, the iceberg would have evaporated, he told Life Science. Loeb also said that hydrogen icebergs are expected to come from the giant molecular clouds, not part of space like Carina or Columbia. And he reiterated that no hydrogen iceberg could survive the trek from the nearest giant molecular cloud. In other words, he's left it open. So what's your thoughts on Oumuamua? Do you actually think it's an alien ship? I think so. I think we were actually visited by a scout ship. And it's very strange how it came by again, not just once, but twice. And it's kind of slingshot around the sun and then came back around again, back on its journey. You never know. We may see it again. I'm going to leave you with a short film on what I believe Oumuamua actually is. Leave your comments in the section below. I'd like to hear your thoughts on this. Thank you for listening.